Good evening, everyone. Thank you for coming out. My name is Logan Wright, as most of you already know, and tonight I'm going to be presenting on supercells for my public speaking class. Did you know that in May of earlier this spring, a long-track supercell made its way through eastern Kentucky, producing an EF4 tornado, killing 19 people. It left many casualties and caused millions of dollars worth of damage to homes and businesses. According to the National Weather Service, only 30% or less of supercells end up producing tornadoes. Supercells, what are they? A supercell is a thunderstorm with a deep rotating updraft. It has an inflow and outflow boundary. These supercells have wall clouds and tail clouds, and these are the most hazardous type of thunderstorms, creating all modes of severe weather. Today I'm going to show you the three types of supercells and what you need to know to be more weather prepared. First, you have the low precipitation supercell. These are exactly how they sound. They have a low liquid content, and these are smaller in size but can still pack a punch. According to the University of Illinois School of Earth Science and Environment, the radar of the small storm can be drastically underestimated. This is due to the low liquid content, and the radar beams cannot pick up the liquid in the air, making it harder to track. These have tight reflectivity on radar, and they have a hook. And this is where a tornado would be produced if there was a tornado in this supercell. Moving on, we have the classic supercell. These are the most common type of supercells. These are the easiest supercells to spot by the naked eye and on radar. According to the Iowa State University, tornadoes in these storms can be seen at some distance and off to the right. These supercells have a wall cloud and a rain-free base and a textbook appearance on radar. As you can see, it has a nice hook, and right here is where a tornado would occur. Usually these tornadoes and supercells can occur in the Midwest and Great Plains, but since Tornado Alley is shifting eastward, we're more likely to see more of these storms. Now, last but certainly not least, we have heavy precipitation supercell. These supercells have heavy rain and hail, extensive hail, wind, flash flooding damage, and these are the most dangerous supercells. The reason being, if there is a tornado in these supercells, due to the heavy rain, these tornadoes can be rain-wrapped, meaning to the naked eye, these will be the hardest to detect, and if you are in the path of one of these storms, you will be caught in the most danger. According to the University of Illinois, the warm southwest air meets the Gulf air, the warm, muggy Gulf air. And if that air is able to push through the southwest air, it can lead to rotation. This can cause rotating storms, heavy precipitation supercells, and dangerous tornadoes. This is the Kentucky tornado count of the last 5 years. As you can see, besides a spike in 2021, we've been on a steady climb of tornadoes counts in Kentucky. This is only likely to increase as our climate changes and Tornado Alley shifts more eastward into our region. Low precipitation supercells. These supercells are the hardest to track on radar due to the low liquid content, but they can still produce all modes of severe weather and can still cause dangerous tornadoes. Classic supercells. These are the most classic supercells, the most common supercells, and these occur mostly in the Midwest to Great Plains. Heavy precipitation supercells. These can be the most dangerous supercells due to the heavy precipitation and extensive wind and hail damage, and if there is a tornado inside, it can be rain-wrapped and very dangerous. These are the references I used: the University of Illinois, National Weather Service, and the Iowa State University. Thank you all for coming out. That is my presentation on supercells, and now you'll be more weather prepared when a storm system moves into our area.